Good evening, all. Welcome to NPTEL online certification program and welcome to the course of Biophotonics. I am Jijit, an interdisciplinary research scholar of IIT Madras, and I will be your PA for this course. Just wait for people to join here. Today, we will be doing a revision program of our course. Hopefully, this is the last PA course for this course, and I hope you people are enjoying this course and you people able to do the assignment problems in a proper manner. And I'm wishing all the best for your coming examination. Let's wait for some time to start our revision of our assignment problems, which is already solved. Okay. Let us start our discussion. This time, actually, we will look the week two assignment problems. We will go through the detailed solution and we will explain that, such that it will be useful for your examination. So here I am directly going through our solved questions. So, so the question number one. What term describe the phenomenon where the light changes direction as it passes from one medium to another? There are four options. One is absorption, second is reflection, third one is refraction, and fourth one is transmission. Now we know that the answer is refraction. So let us discuss what are these different phenomena which is already given in the question. Absorption. What's the phenomenon of absorption? When light is actually passes from one medium to another, some part of the light is getting absorbed. The energy or the photons of the light is getting absorbed. The phenomenon is known as absorption. Okay. So what happens if the absorption occurs? There is one medium. The light is passing with the intensity I naught. And if there is an absorbing medium, what happens? Some part will be get absorbed by the medium. Some solid point. So when it is passes here, actually what happens? The intensity of light is getting decreased, and when it is coming out, the intensity will be low. Yes, I. So if we check the decrease in this distance, this is I naught. This will be decreasing in an exponential manner. Okay, and this question is governed by Beer-Lambert's law, which is saying that I is equal to I naught e raised to minus epsilon. Okay, the same thing we can write in another form. I by I naught equal to e raised to minus epsilon d, or take the log in the two side, log I by I naught minus epsilon d, or epsilon d is equal to Li. This epsilon will actually comprise of the nature of the medium as well as concentration of the medium. So, if we consider it as a some gas or a liquid with a particular absorbing entity, we cannot see epsilon naught. So, so epsilon c ln a naught by I, or it can be 2.303 log I naught by I. Take this constant and this also a constant. So this epsilon by 2.303 can be written as into C into T log I naught by I. This value we will call molar absorption coefficient. Some C log A I naught by I, it terms as absorbance. So absorbance equal to molar absorption coefficient epsilon C. This is called, this L and D are same. So this is like the distance of the length. So this is the law which is governing absorption, and this is called the Beer-Lambert's law. Okay, that is the case for absorption. Now reflection. What is reflection? Reflection is the phenomenon in which light is getting reflected. Light is getting reflected when it sits on a medium. When it is sitting at the surface, the light beam is coming and hitting at a plane surface. What happens? At the interface, light is getting reflected. Theta incidence and theta reflections. And law of reflection is given by theta I is equal to theta R. Angle of incidence is equal to angle of reflection. So there are different kinds of reflection. Like a reflections happening on the mirror where we are looking our face and we are seeing our proper image kind of thing. So that kind of reflection, the reflection is happening in a smooth phase where all light is getting reflected in the proper manner is called specular reflection. Example is the reflections happening on the face of a mirror. This is called a specular reflection. Just see the reflection which is happening on some irregular surface and other things. So what happens? We will not see any images. Here also law of reflection is still valid. Here what happens? But that surface is not smooth, so reflection happen like this way. So other way it is happening in the same direction. But here it is reflect like that way. Here. So the reflected light rays are getting reflected at a different directions. So this will not create a proper imaging kind of reflection, like the reflection which is happening on the mirror surface. So this kind of reflection is called diffuse reflection. This may not produce a proper image. Okay. This this kind of reflection is called diffused reflection. Okay. These are the some information about reflection. Refraction. What happens in the case of refraction? Refraction is the phenomenon in which light changes its direction when it is passes from one medium to another. So now before that one we'll tell transmission. What happens in the case of transmission? When light passes one medium to another medium, this is called passing of the light is called transmission. Now what happens in that case? So if there is a medium have a different properties, so the properties of light, the property which is related to the passage of light through a medium is called refractive index, usually hmm, denoted by n or mu. Okay, so this is called refractive index. So refractive index of different medium have different values. So I will say based on refractive index. If the diffractive index of medium is high, we called denser medium. Diffractive index is low is called rarer medium. So what it is depends on denser medium means rarer medium to denser medium. The velocity of light will be higher in denser medium compared to the rarer medium. That is the difference. The velocity of the light will be higher. And velocity of light, when we are saying about light, it's actually light of a particular wavelength. So refractive index automatically refers that there is a refractive index at a particular wavelength. Okay. So what happens in the case of a light which is traveling normal, there will not be any proper, means there will not be any change. Light will pass through one medium to another. Only the thing is that the velocity of light here will be a little bit less compared to, let it be denser. So there. In the case of a normal incidence, this is called normal incidence because the angle to the normal of the surface. The light is passes through the normal of the surface. Normal is perpendicular to its surface. So this is the normal of the surface, and the light is also passing through that surface itself. So this is called a normal incidence. So in the case of a normal incidence, light is passes with a velocity which is less in the case of rare medium. But what happens in the case of when angle of incidence is a particular angle? In that case, this is surface and drawing a normal to the surface. When light is incident at a particular angle, what happens? It will bend towards the normal. It's I. It's R. If N2 is greater than N1, then I will be greater than R. And how it is quantitatively depends, that depends on the Snell's law. This is given by N1 sine I equal to N2 sine R. N1 or sine I by sine R equal to N2 by N1. Okay. We will see one of the, what happens if angle of in the medium, and what happens if the light is getting moved from denser medium to rarer medium. So N1, N2, N1 is less than, sorry, N is greater than N2. This is the normal. So I R, so N1 sine I equal to N2 sine R. Still this Snell's law will hold here. Here angle of incidence will be higher. sorry, angle of incidence will be lower compared to angle of refraction. Now the same condition, what happens if in this condition, if angle of incidence, if I increased, what will happen? I increase my angle of incidence. Angle of, so if I increase it beyond something, the angle of refraction will be 90 degree. So that the refracted ray will graze through the surface. And that particular angle at which angle of refraction is 90 degree is called critical angle, or it's called C. So in that one, what will happen? N1 sine C will be N2 sine 90 degree. So this will be 1. So N1 sine C is equal to N2, or sine C will be N2 by N1. Okay. And make sure think this N2 by N1 is actually now is a less than 1. This is a refractive index of rarer medium with respect to the denser medium. Usually we will tell refractive index like a denser medium with respect to rarer medium. So like it is like air, and it is sorry, suppose this is glass, this is air. So usually we will say velocity of glass with respect to air, because air brightness is usually 1. So what happens? So in that case, it will be like N2 by N1. So it's the 1 by Ng, or Ng will be 1 by sine C. Okay. So what happens if we increase the angle of incidence beyond the critical angle? If we increase the angle of incidence beyond the critical angle, let it be this is the critical angle. But what happens if we increase it? So the light will obey the law of reflection, and it will completely reflect back to the denser medium. I, so it's that theta I into theta r. Actually, there is no particular coating and other things. This is actually just an interface. So at that particular interface, that all light will actually reflect back to its denser medium. This phenomenon is known as a total internal reflection. Total internal reflection, or TIR. Okay, and this is the phenomenon which we are using in the case of an optical fiber cable. We will discuss the optical fiber cable in a moment. Just think about all these things just now. We'll discuss about optical fiber cable now. Okay. Let's continue the discussion. So we discuss the instrument or the device which can use based on the total and reflection. It's called the optical field. So there will be core with a denser medium, and above that there will be a cladding, which is based on a rarer medium. So what happens? So just consider light is incident from air. It's coming from air. It will cause some refraction here. Angle of incidence here. It is greater than critical angle. What happens? It will till the fiber is not too bent. Always the condition for total and round reflection is satisfied, and the light is air to the passes through from one end to the another end. So now this angle is called acceptance angle. This is the so we can see that there will be a maximum angle at which light can be incident or given inside the fiber. What happens as we are increasing the acceptance angle? As we are increasing the acceptance angle, this will go like this way. And if you are increasing more, there will be a condition at which this angle may less than critical angle such that this light may leak out. So there will be a maximum angle at which the light can be incidence. So that is called the acceptance angle that at which the total reflection can be. And the sign of that acceptance angle, or if there is no refractive index here, this is the acceptance angle theta. This will be sine of sine theta. So n1 sine theta, if the angle of refractive index of the outside medium is here, and this is called the numerical aperture of the optical fiber. The refractive index of the outside medium into the sine theta of that particular acceptance angle. If you are considering this is that whole cone as the acceptance cone, then numerical aperture is the half of the sine of the half of the acceptance angle. Okay. So So you can see that with the one question we discussed a lot of things. Now we will go to the second question. In the context of light matter interaction, what is responsible to the color of an object? Absorption, transmission, reflection, dispersion. Now we see what is absorption, transmission, reflection. Transmission we already talked. Reflection also we already talked. In the case of transmission, what happens? The light is transmitting from one wave to another. In the transmission phenomena itself, there are different phenomena happening. One is actually absorption, because when it is light is getting transmitted, it's getting absorbed. But if you're merely considering the passage of light from one medium to another, we are not considering about the absorption. In the case of transmission, actually there is nothing is coming there. So light is just passing with a change in its velocity. Okay. In the case of reflection, what's happening? So we are only considering the reflected light. So light is incident at one plane and getting reflected from there itself. So in the context of the light, it is getting reflected. There is no change happening in the case of only the change in direction of the propagation is changing. So that is the reflection phenomenon. Now see what happens in the case of absorption. We already discussed absorption, but what's happening in the absorption? Some of the light is actually getting absorbed. Now think that if there's a selective absorption is happening, so if there are some medium, so a polychromatic light is coming. A polychromatic light means a colors light with different wavelength. It's a mixture of wavelengths. And there is a medium which will absorb the this light. What happens? Except this light, all other light will get transmitted. So what happens? The effect of light which we are seeing from here is different from the effect of light from here. So if we look through here, what we will see? We will see the effect produced by this light wavelength. So we will see this material in the color of the effect of this tree. What is determined by this effect of this tree is actually the light which is absorbed. So this light is getting absorbed, and as a result, we are seeing that light which is not absorbed. So actually, this is the one which determines the color of the material. So you can see that each material has a different properties such that it may absorb some different wavelengths when a polychromatic light or a white light is passing or incidentally on it. So that actually determines the color of that object. Okay. So the answer is absorption. The color of an object determined by the wavelength of light that absorbed by the object's material. Okay. Which of the following materials is most likely to exhibit a strong absorption in the visible light range? Transparent glass. Just see transparent glass. What happens? It is transparent means it will pass all the wavelength which is hitting on that. That's why we are seeing that glass in the form of transparent. We are not seeing any color after light is passed through also. That means it will not absorbing all the light, it's passing all the lights through it. A black pepper. What happens in the case of black pepper? We are seeing it as black. Black is actually there is no color. The absence of color is actually we are experience it as a black. So what happens when a white light is incident on it, the whole light is actually absorbed by the material. That's why we are seeing the material as a black. So that will be the answer. See the other option. White marble. Why we seeing the color as white? Because most of the light is actually reflected by that thing. So that's why when a white light is incident on a marble and we are seeing it as a white also. So what's the reason? So it is not absorbing all the color. We are seeing most of the color back. So we will see it as a white. Polished metal surface. Polished metal surface is like we are seeing it's like a mirror. That means and the all light is incident on it. Most of the light is actually reflecting back. So there is no diffuse reflection. That's like a specular reflection. In the case of a white marble, we are not seeing like a reflection like a mm, glass. So that is we can say that is a kind of diffused reflection. Whereas in the case of a polished metal surface, it will be a specular reflection. So here the answer is B, black paper. Just go through that questions. ഹലോ ഞാൻ ക്ലാസ് എടുക്കുന്നു ഇത് കഴിഞ്ഞിട്ട് വിളിക്കാം ക്ലാസ് എടുക്കുന്ന അതെ ക്ലാസ് എടുക്കുന്നതെന്ന് ഞാൻ ഒരു 5 മണിയാകുമ്പോൾ എത്തി ആ Going to the next question. What happens to the speed of light when it enters a medium with a higher refractive index? We already discussed what happens when the light enters from air to a medium, the light velocity decreases. So when it is going to air to medium means air is there is no medium, it's empty. Then when it enters to a medium with the higher refractive index, automatically the velocity of light getting decreased. So the answer is when light is traveling in a medium, it is a vacuum. It has the velocity c. When it is enters to a medium, it has a refractive index n. When it is passes through the medium, the velocity v. Then v is equal to c by n. Or refractive index n can be written as the ratio of c by v. Or we can see that n2 by n1. Sum of n1 to c by v. So when now we can see that c is the maximum speed of light. So c by v always will be greater than 1. So n2 by n1 will be always be greater than 1. So n2 has a higher refractive index compared to n1. So whenever light is traveling from a medium of rarer medium to a medium of denser medium, what happens? The velocity is actually getting decreased. Okay. So B decreases. Which of the light matter interaction responsible for the blue color of the sky during the day? So reflection, we already told that. Absorption, we already discussed it. Refraction, we already discussed it. Now the one is pending, that is scattering. This is what happens when light is getting scattered with the matter. So what is happening in the case of scattering? When light is interacting with particles, which is comparable to the wavelength of the light, is scattered at different directions. And Rayleigh scattering, saying the scattering amount amount of the light scattered is proportional to 1 by lambda raised to 4. So what happens if a light having lower wavelength will scatter most compared to light of higher wavelength. So what happens in the case of light in in the morning in the sense that in noon. So white light is coming from the sun. The white light is coming from the sun, actually interacting with the different particles, dust particles and the water droplets in the sky, and it is getting scattered. This is the atmosphere. So when light is coming like this way, so what happens? The most of the light which is getting scattered will be in the lower wavelength region, like violet, indigo, blue. This thing will scatter in all direction. This will scatter all direction. This will scatter all direction. So whenever we are looking here, whatever the light which is reaching our eye will be the scattered light, and the non-scattered light will travel like this. So we will see the sky in the form of a scattered light. So most of the light scattered will be in the blue region. We will see the sky in the daytime as blue. But what happens in the case of evening? In the case of evening, when we are seeing, so that's the atmosphere, when we are seeing our sun, the light is actually travels long, and we are seeing that. Sorry. So when the light is reaching here, most of the blue side wavelength, they're scattered here and will get lost. So whatever is reaching here is unscattered light, which is actually in the red wavelength region. So we'll see the night sky in the or the evening sky, not the night sky. The evening sky in the form of the red, which is actually the remaining light from the visible spectrum, which is not scattered. Okay, so this is the same reason for the noon sky is actually seeing in the form of blue in color, and also the evening sky and the morning sky, which we are seeing in the form of red in color. Okay. Okay. So The light matter interaction, which is responsible for the sky during the day, is scattering. Ray scatter responsible for the blue color of the sky, where short wavelength blue is scattered more than long wavelength red light. Okay. Going to the next question. What is the term for spontaneous emission of light by an atom or molecule after it has absorbed a photon? So the answer is here given it as a the reflection. We know there is no absorption is happening. Refraction, also there is not absorption is happening. It's an instantaneous phenomenon. Reflection is an instantaneous phenomenon. Refraction is an instantaneous. Scattering is an instantaneous phenomenon. Now, other one is a fluorescence. Fluorescence. How fluorescence occurs in the case of a light. When a particular molecule have a particular band gap. This is the ground state. When light is getting absorbed, when light is getting absorbed, if that particular light has this particular intensity or the energy, sorry, intensity, the light is getting absorbed. After the phenomenon called internal conversion, some energy is getting lost in the form of white break mode of heat transmission, and the is emitted in the form of a wavelength, in the form of a photon with a higher wavelength. And this phenomenon is called fluorescence. It is happening in a around nanometer time scale. So it is getting absorbed. It is making the molecule from ground state to excited state. Then some of the energy is lost in the form of heat. Then the transfer of the excited electrons happens from excited state to the ground state with the emission of a photon having a higher wavelength, means a lower energy photons. And this phenomenon is called fluorescence. Okay, so the answer of that question is B, fluorescence. Okay, Next question. What is the primary difference between fluorescence and phosphorescence? Fluorescence involves short-lived excited state. Phosphorescence involves short-lived excited states. Fluorescence involves longer-lived excited states. Phosphorescence involves longer-lived excited state. So we here we see that in the case of fluorescence, what happens? Excitation usually happens at the femtosecond range. Then there are some time for internal conversion, and then emission. It's called fluorescence. So the lifetime for that one is around nanosecond. So in the case of phosphorescence, it may change from microseconds to milliseconds. So what happens? There is a other than excited state conversion. There is an intersystem crossing, and there is a transition from this singlet state to a triplet state is also occur. So usually in the case of a fluorescence, the lifetime is less, but in the case of a phosphorescence, lifetime is more. So we can see the fluorescence has a short-lived lifetime compared to phosphorescence. So I'll share the screen. Hope you're seeing the screen. So going to the question number 8. How does the band gap of conjugated material influences their electronic properties? We'll see what happens in the case of when conjugated material influences the when the band gap of conjugated material influences the electronic properties. In the case of conjugated materials, what happens when different species are involved and produce a band gap other than a single material? When different species are involved, what happens? There will be valence band having a lower energy level and a conduction band. In the case of when these bands are getting broader, the band gap between them is actually getting decreased. So what happens in the case of a conjugated material? A wider band gap increases electrical conductivity. Band gap is actually what happens is decreased. So actually electrons can move from this lower band to higher bands easily. So what happens in the case of a conjugated material? Narrow band is happen actually getting narrowed, and that is actually increases the electrical conductivity of the material. Okay. So what happens in the case of a conjugated material? A narrow band gap increases the electrical conductivity. A narrower band gap in conjugated material allows for the easier movement of electrons, leading to increased electrical conductivity. This property is crucial for applications such as organic semiconductors. Okay. So moving to the question 9. What term is used to describe the phenomenon where an incoming photon interacts with an atom and induces the emission of a second photon with the same frequency, phase, and direction? Let us see that there are four answers given here, which is absorption, scattering, stimulated emission, and fluorescence. Now we will see what are the three different types of light matter interactions when a light passes from through one medium. So I'm just making like a ground state, excited state. So if a light is coming here and the light has an energy which is similar to that of the energy gap between this ground state and excited state, these electrons can jump by absorbing one photon and it can go to the excited state. What is happening here? Light is coming here, light is getting absorbed, electrons are getting excited from ground state to excited state. And this phenomenon is called absorption. And absorption is a non-radiative phenomenon. It's like a we can say non-radiative thing. Yeah, the thing is that light is getting absorbed, light is actually consumed. So light is coming, light is actually consumed, and it causes electron from jump from ground state to excited state. This is the normal absorption. Now what happens In the case of an excited atom, the light can, sorry, the electron cannot stay there for a long time because that excited molecules having a short lifetime, and always all the electron will try to get its stable lower energy state. So the electron will jump back to its ground state with the emission of the photon, which have the similar energy between these two energy states. So this is somewhat like a light is getting absorbed similar way in the other opposite manner when the electrons are coming from excited state to the ground state, the light is getting emitted. So this is happening. This is a absorption, or we can see this is a stimulated absorption. Why is stimulated? Some external light is required. But if the molecules in the excited state, we don't have to do anything to get a light back. So that's happening in a spontaneous manner. So this emission is called a spontaneous emission. Now consider the third case. If the light, if the material is already in the excited state, and when we are giving a photon which have a same energy corresponding to this band gap, what happens when this photon is interact with this electron, the electron will go to the ground state with the emission of one photon. Along with the photon, which is actually given for that, given to the material. So what happens is we are giving one photon, we are getting two photon, but this is not like a random two photon. The thing is that these two photons will have a equal phase relationship. So both will vibrate in the same manner and it will move. So it is like a twin. So this phenomenon of emission of photons is having the same amplitude and frequency and phase with the emission of light to the material, which is already in the excited state, is called stimulated emission. So we are giving one photon and we are getting two photons with the same phase. Stimulation is the process where the incoming photon induces the emission of a second photon with the same frequency, phase, and direction. So, so what is the usage of the stimulated emission? Now, just see that this is happening. Now, I have a material which can induce stimulated emission. So, I have a lot of electrons at the excited state, and I am giving one photon. This will induce another photon. That may induce another photon. So, like that way, we are getting a bunch of photons the same phase. Okay, so this will have a very high intense light with a very high coherence also, because all the photons emitted are in the exact phase. So this will be very useful for some phenomena. So we want a material which can give electrons at excited state. So one some active material which can give lot of electrons at excited state, and the condition of that lot of electrons at excited state and ground state is called population inversion. So we want a material which can give population inversion, and we are pumping the electrons to go at the excited state using some means of some flash lamps or some electrical energy or something like that way. So that process is called pumping, and lot of electrons will have in the excited state, or we will maintain everything in the excited state continuously. We will put two mirror at the two sides. One have a 100% reflection and one have a 90% reflection, 99. 0.9% reflection. So what happens? Sometimes spontaneous emission will trigger the one of the photons to be emitted, and it may go through the axial direction of that material. So what happens? This will cause a to and fro movement of photons along with all the stimulated emission of the excited electrons, which will lead to a very high intense beam of coherent photons. And very high intense beam means this is only the 99.9 percentage is actually getting reflected inside only. So it's only the 0.1 percentage of the light which is produced inside. That 0.1 percentage of that light itself is a very high intense coherent and high powerful beam, and that device is nothing but a laser. It's called a phenomenon is called a light amplification by stimulated emission of radiation, and this phenomenon is mainly working based on the material which can produce a population inversion state with the engineered techniques along with the stimulated emission. Okay. If you have any doubt, I just you can ask. How is the wavelength related to frequency in the electromagnetic spectrum? It's a direct question. How the wavelength and frequency in electromagnetic spectrum is related. So this is a direct question. So we already know that in the case of electromagnetic waves, the velocity is written as c equal to mu lambda, where mu is the frequency and lambda is the wavelength. So C is in the case of a vacuum, C is actually constant, which is C is equal to 3 into 10 raised to 8 per second. So we can see that nu is equal to C by lambda, the nu is proportional to 1 by lambda. So the relationship between frequency and wavelength of light in electromagnetic spectrum is inversely proportions. Either nu is proportional to 1 by lambda or lambda is proportional to 1 by. The real relationship is nu equal to c by lambda, lambda equal to c by d. So wavelength and frequency are inversely proportional. The relationship is described by equation speed of light is a wavelength into frequency. As the wavelength increases, the frequency decreases, and vice versa. It's the thing which we explained. So these are the revision part of the week 2 paper. So hopefully this PA sessions are useful for you people, and hope this will be informative and helps to solve the assignments and other things. So I'm wishing you all the best for your upcoming exam. If you have any doubt, please ask. Okay. So If there is no further more discussions and other thing, I hope this is the
Hello, sir.
yeah, yeah.
Will there be any numericals in this exam?
Hello, yeah, tell.
Will there be any numericals in this exam? Because all these assignments, I have solved all the 12 assignments. There was not a single numerical in that. So, will there be any other numericals?
I'm not sure because yeah, that will depends on the because of this exam is in the online mode or offline mode.
Online, online,
Online
online.
mode, yeah. Mostly that exam pattern will be somewhat similar to our assignment problem itself. So
Okay,
yeah, because last time also this is a similar kind of thing happened, not for this course, so some another course.
okay,
So anyway, you can practice
okay.
some basic numericals, but mainly focus on your
Theory.
content of the things.
Okay. And I have one more doubt. I had actually enrolled for the same biophotonics course last time also.
Okay.
So I have those assignments, but the solutions are removed from the drive. I was searching for the solutions, but now they don't exist on the drive,
Oh, that.
NPTELs.
Yeah. Actually, they will not keep that same solutions after that one, after the same
Okay,
course,
okay.
because the course
I thought,
sometime, yeah, course will
okay, okay.
rerun. So
Yeah,
sometimes
yeah,
they may be using
yeah.
that one for the other
No,
things.
I thought I could refer to that solution also. So
But
that's why I
you,
was searching for.
yeah, but you can get the answers, na?
Yeah, yeah, we
You
can
can
get the
see the
answers. Yeah,
answers, yeah.
yeah,
So
yeah.
yeah, you can actually check if there any doubt is there. You can just put it on that forum such that we may look and answer that.
Okay, okay, sir. Thank you so much, sir.
Okay. When is your exam?
Okay.
Exam date is declared.
28th April.
Okay, okay. Then if you have any doubt and other things, you just put it there. So I think this is the last class for this TS ship. If there is no other class,
Okay,
we will check that one
okay,
and inform.
okay, okay. And hall tickets we have not received yet.
Oh, I think they will upload that one soon.
Okay,
Okay.
okay. Thank you so much, sir.
Okay, thank you.
Okay.
Okay. So I'm wishing you all the best for your exam. All the best and prepare well and do a nice manner. Enjoy your learning. Thank you. So I'm closing the meet. I'm wishing you all the best again. Thank you.